Today we have a lesson on section 2.2, power functions with modeling. What we have here is what's called a power function, which is f of x equals k times x to the power of a, where k is just a constant of variation. K is just a number. A is the power. So, a couple situations that we have with a power function. We have what's called a direct variation, which is when the power function has a positive power. I have an example of this. Y equals 7x to the power of 8. 7 would be your constant of variation if they asked for that. 8 is the power. And since it is a positive power, it is a direct variation. An inverse variation, again, is a power function with a negative power. Example could be this, where y equals 3 times x to the power of negative 4. Again, 3 is your constant of variation. Negative 4 is your power. We can also write this as 3 over x to the 4th. If you remember your exponent rules from the first chapter, we talked about if it's negative, we can bring it to the bottom and make it positive. So that's why it is an inverse variation. In both situations, they just have a constant in front of it. So in your homework, they're going to ask you, determine if the function is a power function. If it is, state the power and constant of variation. So I have a couple examples here. First of all, the first one is f of x equals 10x to the power of 3. And this is a power function. A is going to be 3, and k is going to be 10. So your power is 3, and your constant of variation is 10, and you can just say k equals 10. Number 2 is this one. A lot of people say no because of the j. Well, it actually is, and j is this another, can be a number, so we're just going to call that a constant of variation, and our power is actually going to be negative 5. Again, we want to bring that to the top, and that's going to represent a negative power, which is, again, an inverse variation. So you might ask yourself, is there an example where there is not a power function? So right here, if I have 3 times 4x to the power of 2, this is not a power function. Again, if you think that you can take 3 times 4 to get 12, you cannot do that. That is not the mathematically, you have to square x first and then multiply that times 4. So the 3 is what causes this not to be a power function. A monomial function is where f of x can just equal k, which is just a number, or it can be k times x to the power of n, where n has to be a positive integer. So an example could be 2 times x to the power of 4. That would be an example of a monomial function. Or y equals 10. That would be another example of that. Now, something that you guys probably have figured out a long time ago about even and odd functions. We have discussed this. If the power is even, so if a is an even number, it is going to be an even function. If a is an odd number, then it is going to be an odd function. Again, this works only with power functions because we have no shifting left or right or up or down. We just have a constant in front, which all it does is changes your vertical stretch or horizontal shrink, which doesn't shift the function left, right, or up or down. So again, if the power is even, the function is even. If a is odd, the function is odd. Fairly short lesson today. Your homework for tomorrow is going to be page 189, 1 through 16, 29 to 34, and 41 to 50.